Good morning, students. Today we are going to discuss about the topic is velocity time graph. In the last class we have seen about types of motion, uniform and non-uniform motion, distance and displacement, and the graphical representation of motion along a straight line, the distance time graph for uniform motion. Velocity time graph. The variation in velocity of an object with time can be represented by velocity time graph. The variation in velocity of an object with time can be represented by velocity time graph. In this graph, time is represented along x-axis and the velocity is represented along y-axis. Okay. If an object moves at uniform velocity, we know the displacement is the product of velocity and time. Here, the object is moving in the uniform velocity. Now, we find out the magnitude of the displacement. Now, you can see the object is moving with the constant velocity. So, take 2 points A and B on the slope of the graph. Draw 2 lines parallel to y-axis. Okay, parallel to y-axis. Now, we mark the points T1 and T2. This point is T1 and this point is T2. So, T1 and T2 is the time interval. So, the distance S moved by the object, distance S is equal to AC into CD. AC into CD. CD is T2 minus T1. Okay. So, S is equal to area of rectangle ABCD. Area S is what? Distance. Distance is equal to area of rectangle ABCD. Now we find out the uniform accelerated motion. Here the velocity changes to equal amount with equal interval of time. Consider a car moving along a straight road. Its velocity for every 5 seconds. Every 5 seconds is noted from the speedometer of the car. Okay. So, the uniform accelerated motion. Time, it is measured by second, and velocity of the car, it is measured by meter per second. Here we can see the velocity changes. The velocity changes by equal amount in equal interval of time. Okay. So, the velocity time graph is a straight line. So, the distance S traveled by the car will be given by the particular area A, B, C, D, E. Listen, A, B, C, D, E. So, distance S is equal to area A, B, C, D, E. That is equal to area of the rectangle ABCD. Area of rectangle ABCD plus area of triangle ADE. Okay. Area of rectangle ABCD plus area of triangle ADE. Okay. Now, area of rectangle. Formula L into B, length into breadth. So, area of rectangle ABCD equal to AB into BC, length into breadth, AB into BC plus area of triangle formula half BH. So, area of triangle ADE equal to half into AD into DE. Okay, area of rectangle ABCD equal to AB into BC plus area of triangle half BH, so half into AD into DE. Okay. So, S is equal to distance. S is equal to area of trapezium ABCDE. Listen, ABCDE. So, area of trapezium formula half into sum of length of parallel side into distance between parallel side. Area of trapezium half into sum of length of parallel side into distance between parallel side is equal to half into sum of length of parallel side. Sum of length of parallel side means here AB plus CE, parallel side, AB plus CE, okay, into distance between parallel side, T2 minus T1. So here BC, okay. So S is equal to area of trapezium, A, B, C, D, E equal to half into sum of length of parallel side, AB and CE, okay. So AB plus CE into distance between parallel side BC. In the case of non-uniform accelerated motion, the distance time graph and the velocity time graph can changes any shape. Okay students, now we remember some important terms: types of motion, linear motion, circular motion, oscillatory motion and random motion. Next, uniform and non-uniform motion. What's uniform motion? If the object covers equal distance in equal interval of time is called uniform motion. And what is non-uniform motion? If the object covers unequal distance in equal interval of time is called non-uniform motion. If the object covers unequal distance in equal interval of time is called non-uniform motion. Next, distance. What's distance? The actual length of the path traveled by a moving body is called distance, okay. So it is measured by meter. It is a scalar quantity. It has the magnitude. And displacement, it is defined as the change in position of a moving body in a particular direction. Change in position of a moving body in a particular direction. It is a vector quantity. It's having both magnitude and direction. It's also measured in meter. Next one is speed. What speed? The speed is the rate of change of distance or the distance traveled in unit time. It is very important. Speed is the rate of change of distance or the distance traveled in the unit time. It is a scalar quantity. And the SI unit of speed is meter second power minus 1. And speed is equal to formula distance traveled by time taken. Distance traveled by time taken. Next one is velocity. Velocity is the rate of change of displacement. Rate of change of displacement. So it is the displacement in the unit time. So it is a vector quantity. And the SI unit of velocity is meter second power minus 1. Meter second power minus 1. So what's the formula? Velocity is equal to displacement by time taken. Speed is equal to distance traveled by time taken. And velocity is equal to displacement by time taken. Okay. Next one is acceleration. Acceleration is the rate of change of velocity, or it is the change of velocity in unit time. It is a vector quantity. The SI unit of acceleration is meter second power minus 2. Acceleration is the change in velocity by time. Change in velocity means final velocity minus initial velocity by time. So the final velocity is equal to V minus U by T. Okay. V is the final velocity and U is the initial velocity. So A is equal to V minus U by T. Speed is equal to distance traveled by time taken, and the velocity is equal to displacement by time taken, and acceleration is equal to change in velocity by time taken. Okay. And here SI unit of speed is meter second power minus 1. SI unit of velocity is meter second power minus 1, and the SI unit of acceleration is meter second power minus 2. Okay students, thank you. Today class is over.